वेलकम फ्रेंड्स। तो मॉर्निंग में हमने देखा 10 क्वेश्चंस कैसे इजीली वी कैन सॉल्व ऑल दीज एआई क्वेश्चंस. We just have to take care of some things, some little bit things we have to understand, and AI is damn easy thing. In GATE there are basically 3 types of questions are going to come. 3 types are there. First is search algorithms. So there 3 types are there, that is uninformed search and informed search and adversarial search. Then logic questions, propositional logic, predicate logic, 2 types are there, those questions will come. And third one is your Bayes network, that uncertainty calculations, then exact inference, approximate inference. So 3 broad classes are there: search algorithms, logic and uncertainty, Bayes networks. So on that only everything revolves. So now we will see other things in our AI area. Next 11 questions I will discuss now. So again, as you can see, informed search, uninformed search, logic, predicate logic, propositional logic, approximate inference, exact inference, knowledge representation, these are the topics. So let us solve this question. Decision uncertainty means the predictability of future outcomes or the measure of ambiguity surrounding potential outcomes, the complete knowledge about future events, or the complexity of decision making. So here decision uncertainty we are talking about. So how come the predictability of future outcomes? No, this is wrong. The measure of ambiguity surrounding potential outcomes, yes, measure of ambiguity, this is true. Complete knowledge about future events, no. Uncertainty is there, so how? We don't have complete knowledge. Some knowledge we will have. The complexity of decision making, no, not much it has to do, something it has to do, but the B is the correct answer, the measure of ambiguity surrounding potential outcomes. So the measure of ambiguity surrounding potential outcomes. Let us come to the next question. Consider following statements regarding search algorithms. Uniform cost search is a special case of best first search. What do we do in best first search? We try to find the best node. Greedy best first search is there. We immediately take the cost to from the intermediate node to the goal node and select nodes on that basis. So uniform cost search is also similar only. Uniform cost search also does the same. It calculates the cost. Then A star graph search expands no more nodes than depth first graph search, that we can't say. And weighted A star implementation doesn't need a priority queue. No, it needs a priority queue, otherwise A star implementation can't happen, where it will keep the search results. And A star graph search expands no more nodes than uniform cost graph search. Yes, uniform cost graph search, once it has found, then why A star has to go to more nodes? So 1 and 4 correct answers. Here you see 1 and 4 are the correct answer. Uniform cost search is a special case of best first tree search, yes. And A star graph search expands no more nodes than uniform cost graph search. Now, which data structure is the most suited for implementing uniform cost search? Which data structure is the most suited? Skip list, minimum heap, max heap, queue. So here answer is the minimum heap, because in the heap data structure that costs are organized like this, you see. Minimum heap allows efficient retrieval of the node with the lowest cost, which is essential for the uniform cost search algorithm that selects a path with the lowest cost. So the costs are, see, in computer science, a heap is a specialized tree based data structure that satisfies the heap property. In max heap for any given node C, if P is parent node of C, then the value of P is greater than or equal to the key of C. In a minimum heap, the key of P is less than or equal to the, so the grading is there in the heap structure. That's why it's very useful for uniform cost search. Like this is the minimum heap where the value of the root node, this is a root node, is less than or equal to either of its children. So we can start from the root node and keep on the basis of cost, we can keep on finding the uniform cost search. So this minimum heap is most suited. In maximum heap, opposite will happen. This is the highest and then lowest are coming. So we can't start from this one. So max heap is not suited, minimum heap is suited. Now coming to this question, this you must study. Given the following predicate logic statement. Now this means opposite, not this one, okay. And there exists X, this reverse E means there exists, there is some X is existing, so that this statement is true. As X is a student, X is a student and this is intersection, means X is a student and then both of them, this CX is clever. X is a student and he is clever also, and A is ambitious, he is ambitious also. So there exists an X who is a student also and who is a student, who is clever also and he is ambitious also. So that's what we have to describe in the sentences, that ambitious person is a clever student, not this. Students are neither clever nor ambitious, not this. No student is both clever and ambitious. Yes, here we can see student is both clever and both ambitious, and then there is no. So no student is both clever and ambitious is the right answer here, and no ambitious person is a clever student, that is irrelevant. No student, see this means no student is to SX student, no student is both clever and, this is and symbol, and ambitious. So no student is both clever and ambitious is the right answer. Here you see no student is both clever and ambitious. Like that we can explain how it happens. Then what is the value of the root node? Here other statements which we have made, these are for A, B and C statements, how the shape of the statement will be. Now try to focus on this problem, this is very important. Minimax search, you know, when min-max search happens where we are game playing, means one person makes a move, so he maximizes his gain, and then other person makes a move to minimize the gain of this person. We will talk only context of one person. Like suppose we are playing chess, then we will talk in the context of white. So white will make the first move to maximize his gain. Then black will make his move to minimize the gain of the first player, that is white player. Then third time this white will move to minimize his gain. So white plays to minimize white's gain, black plays to minimize, white plays to maximize white's gain, and black plays to minimize white's gain, and that's how the game proceeds. That itself says that if black is minimizing white's gain, means black is maximizing his own gain. That's how the game proceeds. So here what it says, what is the value of the root node as per minimax search over the given tree? The root node is max node, this is max node. So what this max node will do? It will take the maximum of C and B. That's how this max node works. So max node will take maximum of C and B. Then this C and B will automatically be min nodes. So they will take, C will take minimum of F and G, and B will take minimum of D and E. And further then F will take maximum of these two G will take maximum of these two, D will take maximum, like this. So taking here maximum of 43 and 12 are 43. So here it will 43, here it will 32, and 43 and 32 minimum will be taken. So here it will be 32. So here the value is coming 32, here the value will come 23, here 13, and 13 is less, so 13 will be here, 32 will be here, maximum will be selected, so A will select 32. So that's how C answer 32 will be there. This is the way Minimax search works. Explanation: root node A is max node, so it will take max of B and C. Now B and C will be min nodes, B will take minimum of D and E, as I told you. Now for next question, let us see this definition of uniform cost search. Uniform cost search is an uninformed search algorithm that uses the lowest cumulative cost to find a path from the source to the destination. Lowest cumulative cost, accumulated cost it will take. Nodes are expanded starting from the root according to the minimum cumulative cost, minimum accumulated cost. जितना cost इकट्ठा हुआ है सबसे कम cost पे जाएगा. The uniform cost search is then implemented using a priority queue, as we discussed in the last question. So here the question is, on uniform cost search, the time and space complexities of the uniform cost search algorithm are, so this is order of B to the power D and order of B to the power D, both time and space are the same complexities. B is the branching factor and D is the depth of the shallowest solution. So that's how uniform cost search works. O to order of B to the power D and order of B to the, both time and space complexities are like that only, where B is the branching factor, D is the depth of the shallowest solution. Now coming to the next question, this is a conceptually strong question. Take it. Consider the depth limited search algorithm. You know what happens in depth limited search algorithm? Depth limited means initially itself we define that we will only go to up to this depth and do depth search, depth first search. We will only go to that. If no goal is found, we will go to the other branch, then other branch. Like it's a combination of breadth first search and depth first search. And if it is not found, then we will again come to basic level. So like that, this is there, depth first search, depth limited search. So if F is less than D, then it's complete but not nominal. F is less than D means it will not reach the goal. It will come shallower than the goal. F is less than D. So what will happen? It will not find the goal. So it may not be complete. It's not complete. And optimal का तो सवाल ही नहीं है. Now, if F is less than D, then it's not complete, not optimal. Yes, this is true. It's not complete because it hasn't found the goal. Unless it finds the goal, it's not complete. And unless it finds the goal in the optimum manner, it's not optimal. So it will be complete and optimal only if it has found the goal and it has found the best path. Okay. So F is less than D, second is correct. It's not complete and not optimal. Now if F is greater than D means it's going deeper than the goal is there. So it will definitely find the goal. It's complete but not optimal because there's no guarantee that it is going to find the best solution. It will find the goal, no doubt. And if F is greater than, then it's not complete, not optimal, no, that's not correct. So 2 and 3 are correct, 2 and 3, that's B. B2 and 3. If the depth limit F is greater than the depth D, at which the goal state exists, then the search will reach the goal state, become complete. Now coming to this question, let Px be x is even. Again a predicate logic question. Let Qx be x is odd. I want you to be very comfortable with the symbols being used in predicate logic or first order logic. let Px be x is even and let Qx be x is odd, and let the universe be the set of all integers, let exclusive or operator be there. Now take two statements. This is for each x, Px means x is even. For each x, Px x is even or x is odd, means they can't be both same together. Either x is even or x is odd, that's what it is trying to say for each x. So S1 is right. Now what S2 says? For each x, Px hold true. Oh God. Means for each x, every x is even and every x is odd also. Every x is even or every x is odd, which is not true. Every x can't be even, every integer can't be even. There are even and odd integers. So this S2 is wrong. S1 is true but S2 is false. B is correct answer. S1 is true but S2 is false. You can see the explanation. Now 19th question. You know from experience that the value of a particular state in a Minimax search tree lies between x and y. Okay, we are going to perform a Minimax search here, and you know in the Minimax search x and y in between two this minimum and maximum we are going to work. And now we are going to perform alpha beta search also, alpha beta pruning also we are going to do. So what happens in Minimax search, that one player maximizes his gain, then opponent wants to minimize his gain, means opponent's gain. So it goes like this. And now what happens, that in alpha beta pruning we set two alpha and beta two digits like this, that we try to find out which nodes are useless. There is no point in going to those nodes because their results have already been decided. This suppose we are trying to find minimum of 2 1. Now 1 is already at the minimum level, then taking the other node is of no use. So that's how alpha beta pruning works. So now how can you use this information about Minimax search, that it lies between x and y, x is greater than y. Return value of state as x plus y by 2 we will get, or set alpha is equal to y and beta is equal to x, set alpha is equal to x and beta is equal to y. This information is of no use. So how to solve this thing? So answer is set alpha is equal to y and beta is equal to x. Why we are putting alpha is equal to y? Because alpha beta pruning optimizes the Minimax algorithm by skipping branches in the game tree that won't improve the outcome. If you know the value of a state lies between x and y, and x is greater than y I have taken, that means x having higher value will try to minimize while y will try to maximize. See, in Minimax search and in alpha beta pruning, what we are trying to do, the minimum value, low value will try to maximize. So here what is low value? In the question itself we have given that x is greater than y. So y is the lower value. So alpha will be set to y because y will try to maximize, and beta will be treated. Always in alpha beta pruning, alpha tries to maximize, beta tries to minimize. So when I have put x is greater than y, means the lower value will be put to alpha, because alpha will try to maximize and beta will try to minimize. That's why these values are being set. Suppose if it would have been x is less than y, then alpha will be x and beta will be y. This is the way it works. Now 20th question, which of the following scenarios is most suitable for using an informed search algorithm over an uninformed search algorithm? Like there are two types of algorithms I have told you. Uninformed search algorithm is like blind search. You don't have any information, so you have to search everywhere. But informed search algorithm means you are having some information, so you can have an informed decision. You are able to see, you are not blind, so you can immediately go to the relevant place. So hiker lost in an unknown forest, hiker खो गया है with no map, कोई मैप नहीं है, GPS नहीं है, ना clear direction उसके पास है. So he is lost. So if he has to come out, he will search here and there everywhere. That is uninformed search. You can't apply informed search here. A person in a known city trying to find the shortest path to a specific destination where GPS and maps are available. He has some GPS is there, maps are there, Google map लगा के चल रहा है. Then it's an informed search. There informed search can be applied. A robot vacuums cleaner cleaning a room where the layout and obstacles are unknown. Layout is unknown, obstacles are unknown, where there is optical he doesn't know, that robot vacuum cleaner. So that poor fellow will try to perform uninformed search. He doesn't has the requisite information. A puzzle game where the goal state and rules are undefined. Goal state is undefined, where you want to reach. Rules are undefined, so it's an again uninformed search. So there's only one case which is related to informed search, that is a person in a known city trying to find the shortest path to a specific destination where GPS and maps are available. So that's the key, because heuristic function for informed search algorithm is available. Now this is an important question, a bit complicated one. I will explain it to you. Consider the following Bayesian network. This is a Bayesian network, nodes are dependent on each other. Suppose we wish to compute probability of C over ABD, FE also. So probability of C over all A, B, D, F, E, all the nodes they are taking into account. For running Markov chain Monte Carlo MCMC with Gibbs sampling. So if X is the normalizing constant, which of the following represents the simplified problem that needs to be solved? Whether it's this one, probability of C over AB DF is equal to X into probability of C over AB, or this one, probability of C over AB DFE is equal to X into probability of C over AB into probability of D over C, or this one or this one. So that you can stop this video here and try to solve yourself. How to do it? Now what I am telling you, Markov chain. Markov chain means some node will only depend on its previous node and no other node. It's called a Markov blanket. So a node will depend on its parents' nodes, its children node, and other parent of its children, no other node. And Monte Carlo is random simulation. Gibbs sampling gives the same type of sampling, so that very less information will be required to represent it. Let us see this one. A Markov chain or Markov process is a stochastic model describing a sequence of possible events in which the probability of each event depends only on state attained in the previous event. Informally, this may be thought of as what happens next depends only on the state of affairs now. Only the situation of now will affect what happens next, not previous situations. Markov chain Monte Carlo methods comprise a class of algorithms for sampling from a probability distribution. By constructing a Markov chain that has the desired distribution and its equilibrium distribution, one can obtain a sample of the desired distribution by recording states from the chain. The more steps that are included, the more closely the distribution of the sample matches the actual desired distribution. Now, the local Markov property implies that each node is conditionally independent of the rest of the network given its Markov blanket, which includes the node's parents, children, the other parents of the node's children. So, Gibbs sampling or a Gibbs sampler is a Markov chain Monte Carlo MCMC algorithm for sampling from a specified multivariate probability distribution, when direct sampling from the joint distribution is difficult, but sampling from the conditional distribution is more practical. This sequence can be used to approximate the joint distribution. It generates a histogram of the distribution to approximate the marginal distribution of one of the variables or some subset of the variables, for example, the unknown parameter latent variables, or to compute integers. So, this is the topic which is in the gate, it is there, approximate inference. This is this one. So, in the given problem, Markov blanket for nodes includes its parents A and B, its child D, and parents of D, C and E. Hence, what will happen? Therefore, the simplified problem of C conditional on A, B, D, F, E is from the figure x into probability of C is depending on its parents A and B, and then its child D and child's parents C and E. So, this is the right answer, that is answer B. So, here you can see C will depend on its parents A and B. This is now irrelevant for C. So, as per Markov chain. Markov chain means only immediate nodes will affect. So, C will be affected only from A and B, and then its child D, and D's parents is C and E. So, that is why this is correct. Probability of C A, B, D, F is equal to x into probability of C over its parents A and B, that is the Markov property, into P D over C. Then it will take its child D and child's parents C and E. Okay. So, this is the way we have to solve this gift sampling or Markov chain algorithms, MCMC. Also, it is called metropolitan something, it is like that.